Alrighty then. So what I've got going on here, and I'll only post this video at some point if I think I'm not going to get any huge amount of grief over it. What I've done is I've purchased one of these AC volt amp meters that'll measure up to 200 amps and 300 volts. And I'm going to mount it in one of these, and then I've got it hooked into my what do you call it, my circuit breaker box. And the problem with it is I wanted to measure the total amp draw for the circuit breaker. So let's say we have, in my circuit breaker box, we have two 120 volt lines coming in and then a neutral. And I have room for, I think it's 6 total circuits, of which I'm using 5. 3 are on one side, 3 are on the other. Now, if I have a load on one side of 10 amps, and I have a load on the other side of 15 amps, if I want to measure the total amperage of the box, theoretically I need to have 2 of these. But I was doing some research, and boy, what a controversial subject. Any questions on any forum about doing something similar to this just erupt into a war of things about what you can and can't do in circuit breaker boxes, and what does work and doesn't, and split phase, and I mean, it just I couldn't believe the amount of vitriol that was in some of these forums. So I tested some things, and one of the things that people suggested doing, but nobody apparently has ever tried, is this thing uses a current transformer. I can't show you because it's installed in the box, and I'm not going to open the box, the circuit breaker box. So pretend this is a current transformer. Now normally you have 2 wires coming in and a neutral. I'm not going to worry about the neutral because you don't ever measure your amperage off the neutral. Now if you take this and you run both wires through here, even though they're both 120 volts and they have different loads, you will get a reading of 0, because due to the fact that everything is it's split phase, and the loads are 180 degrees out of phase, you get 0. Many people suggested doing this, putting one side in this way and one side in this way, and but they said if you did this you had to divide by 2. Well, what I found is that the way mine is I've got one side coming in like this, and it goes into one side of the box, and then on the other side I have the other half coming in this way, going to the other box. And by doing this, they're now seen by the current transformer as a single AC source. Basically they're in phase. Now I haven't hooked it up yet, but the testing I did showed that if you take and you do it this way, what you get is the total amperage being drawn by the box. Like I said, if you have one side that has 10 amps drawing and the other side has 15, you add that up, you have 25 amps coming into your circuit breaker. If you do this, it shows 25 amps. Now, I'm not going to get into whether those are real amps, reactive amps, capacitive amps, resistive amps, imaginary amps, or any of that. All I know is that if I'm pulling 10 amps on one side and 15 amps on the other, I will have a total of 25 amps coming through my circuit breaker box. And that's what I'm measuring. So when I get this all set up, we'll test that out a little bit and see what this says. Okay, so here it is hooked up. It's showing 0 amps, mostly because I don't think it's sensitive enough to pick up when my shop is just running with lights on. Nothing major running. It seems to only pull about 1 amp, and it may be a little out of adjustment, but that's alright. So what I'm going to do is I've got 2 heaters, each of them 1500 watts on 2 different circuits. And so we're going to turn on one, and this is 1300 watts, 1500 watts, and we're going to turn on the other one. That's 750 watts added, and now 1500 watts. If this was on a single circuit, it should trip, because 24 amps over a long period of time should trip the circuit breaker. But anyways, as you can see, if I turn off one, the reason the voltage drops is I have the this thing hooked up to get its power from a plug strip, and I don't want to hook it directly into the mains. That would be kind of dumb. It does have a fuse, as you can see. I looked up the specs on this thing, and it says it draws 200 milliamps, so that's a 500 milliamp slow blow fuse. In case this thing somehow a component fails or whatever. Also, the reason I've got it on the separate on the plug strip is when I leave my shop, I turn off the plug strips, and I don't want this thing running when I'm not here. I don't really want anything running in the shop when I'm not here. So we'll see how this works.